Hello, welcome to Point On Studio. My name is Jungho Park. Today I'm going to show specific workflow using Grasshopper and Rhino in Grasshopper to generate analytical model automatically out of imported 3D DW file. I was working in interdisciplinary office where architects and structural engineer and civil engineer or MEP engineer all work together in the same office, and sometimes it's a bit very tedious work to organize a structural model out of Revit to be able to calculate in calculation software such as SOFiSTiK or I don't know, RFM, Oasis, and many others software. It's really difficult. Always like there is misunderstanding between architectural model and structural model, and then maybe the architectural model is too detailed with so many openings. So it's really a lot of hours to modify structural analytical model. So here is this is a simple idea. We import, let's say, instead of organizing in Revit or ArchiCAD or Bentley, we just export the geometry out of the beam authoring software and then import the 3D DW file in Rhino, and then we can use Grasshopper to extract and modify structural analytical model automatically, and then we just use SOFiSTiK plugin for Grasshopper and calculate it, and boom, finish. So that's what I wanted to show today. Okay, let's have a look. So let's say we import this 3D DW file from structural engineer, and as you can see right now it's a little bit doesn't make any sense for realistic building, but I just put any kind of typology or prototype of openings for the internal wall and also different columns and slabs and foundation. And when I go to wireframe, we can overlay this sort of geometry. And now I'm going to turn on Grasshopper, and as you can see in here, the Grasshopper shows analytical line model and analytical surface and lines. So for example, blue is like analytical area surface, and the blue lines are from analytical lines from structural framing, and red lines is out of the column elements. So let's say, and also the green points, they are node points, the start and end points of structural members. And you can see what could be a good example. For example, let's look at column. The column geometry, if you just look at the physical geometry, they are starting from top of the slab and finish at the bottom of the slab. So when we look at the analytical model, it may be just not connecting to the middle of slab, because structural engineer, most of case, they prefer to have analytical surface of the slab in the middle position of the slab. So when I look at the wireframe view in Rhino, and in this case, the analytical lines are elongate to the middle of structural surface, so it connected, and which is happening for the wall as well. So if you look at the wall, they are finished also. The top of the wall is finished bottom of the slab, but it's automatically elongate to the analytical surface. So if I move it, of course they should update automatically. And the columns, if I move it, of course it updates, and when I give rotation angle, so that analytical lines is automatically attached to the slab. And this can be modify the position of the analytical models. Let me just move this Rhino and put the Grasshopper script here. So for instance, now we have here the surface of floor, and right now the position is in the center of the slab thickness. But when I move this to top of the slab, and as you can see, the slab analytical surface is moved to top of the slab, and accordingly all the points and node points and the analytical lines update. And let me put them into the bottom, and as you can see, it updates as well. But most likely structural engineers prefer to have this structural analytical surface in the middle of slab, and which goes same without saying for the wall. For instance, when I go to wall here, you can see it's in the middle, but we can also control if, sorry, this is still for center left, so sorry, that's for the exterior wall. And in interior wall, if I go from center to left, as you can see, this analytical surface, they are moving. But again, most of case we put it in the center, so I leave it center. And yeah, it's just very simple script, but it automatically update analytical model, as you can see. If it go too much beyond, it doesn't work there. So we can also control the tolerance. It's just matter of changing the script. And the script is simple. When we import DWG file, we reference layer name by using pipeline, and just a little bit of data structure, analyze the organizing, and then eventually we can get analytical surface. We can also make this wall, for instance, with opening or without opening. So sometimes if there is small openings, we can completely ignore and just use it as a analytical model, or we can also leave the openings so we can calculate with the openings. What else? So the blue is like structural beam, and this script here, for instance, the beam between the column, it will project the line and then it elongate to between the columns, so that node points 100% match each other. Yeah, you can also, I guess you can also make a slanted wall, then it elongate and then attach to between the slab, so we can have exact analytical model. Or maybe I just have to change the tolerance, but theoretically it's possible. Let me go to wall. It just let's see. We have yeah, just okay, in this case, alright, because of the script is at the moment is draw, I made it only for the vertical wall, but if we take the index of this wall and then make it to different vector, then we could definitely do it for the angled wall as well. So I mean, that's what I'm saying. This scenario is maybe not 100% work for all kind of situation, but at least, you know, when you have logic, you can modify the script and then it could work. Now what I'll do, I'll maybe show some more openings on exterior side of the wall. So to do that, I'm going to create some box manually in Rhino, and I'm going to move it here, one opening, and maybe another one somewhere here, let's say another window and there. And I'm going to use Boolean difference. And maybe I didn't put enough, but here we have now openings, and accordingly we create the let me undo. I'll push a bit here in, and then let's make again boolean difference for that. Yeah, so we have here this opening, and I'm going to make another box here, and let's make geometry a bit different so we can test here. In this case, I'm going to push it in there, maybe rotate a bit, and I'm going to make another boolean difference for this wall here. So we have openings and we have again the analytical model. So it works perfectly, and that's what I've done here for the interior wall. Let's see. What I'll do? I'm going to now use SOFiSTiK plugin for Grasshopper, and then we can convert all this analytical model to calculate. So let's preview on, and as you can see now we have load cases and also the SOFiSTiK model based on the current analytical model. So let's see. With SOFiSTiK, I'm just going to automatically synchronize my TedD file, and in SSD I can just recalculate the script, and when I calculate linear analysis, and you can see now it's calculated. So if you compare the model between Rhino and SOFiSTiK model, maybe I'll make it to shaded view. So as you can see, it's a little bit crazy model, but nevertheless, so you can see that that everything came correctly. Yeah, the member is not assigned correct. So actually these two supposed to be the circular member, and that should be the rectangle member. But nevertheless, anyway, it works. And let's have a look the deformation based on load cases. So we have dead load, it works perfectly, and then we have live load 1 and live load 2. So it works, yeah. So let me try in Rhino quickly change a bit of geometry. I think wireframe is always better, and maybe I'll delete this column and I'll rotate this quickly here, like it's out of the range, and elongate it, and perhaps here I'll rotate this direction, move it, works, and I'll move this wall another position, maybe I'll rotate here the wrong direction. Maybe let's make some more openings. So I'm going to make this time a sphere, and this sphere I'll put somewhere on the wall. Let's see. And then I'm going to make a boolean difference. So we have 4 and we have analytical model. Maybe let me make another small sphere, this time a little bit smaller, and this sphere I'll put it, yeah, it's going to be interesting to put it here in another opening. Boolean difference. So we have this sort of analytical surface. I'm going to modify this edge of the wall, and of course our analytical surface updates. There's a collision between the columns, so I move this wall a bit further, and yeah, maybe this column position is a bit, I'm gonna push it to there, and we have now kind of updated model. Maybe let me delete this column and this column, maybe slant this column. So now obviously our structure changed. Now let me maybe here I'm gonna make a bigger opening, and let's make a bit here polygonal shape also, so everything is updated. That's nice thing about this Grasshopper. So we don't have to get any stress to arrange and organize your analytical model, because Grasshopper does everything for you. And this data from so basically this script is automatically actualize the TEDdy file, and all I need to do in SSD just calculate Grasshopper input, and again calculate linear analysis, and we have already updated model here. So it's nice, everything updated, and we can see dead road, live road, first live road, and then you can see the dead road too. But what I found is strange that the word here on level 1 is deleted. That's funny. Let's have a look. Yeah, this word is gone. I don't know why. Here this word is exist. That's, I don't know what happened. Let me move it a bit, and let's calculate it again. So still that word is disappeared. Probably that geometry was too much. Let me undo. Yeah, that's interesting. Maybe I'll just leave it and then calculate it. Let's have a look. So wall is there, back to normal. There's collision, you can see. So that wall, I'll move it a bit further, and perhaps I'm just curious now. I'm going to make another small cylinder sphere here, and let's make a boolean difference for this. So okay, my script just straighten it so at some point, and then it make polygonal because of the actually my script is correct, but from SOFiSTiK's analytical model, if I turn off the SOFiSTiK script, it automatically connect and make it polygonal, so it doesn't make here in this shape. No, actually the Grasshopper definition also couldn't make it. That's the reason why. Yeah, it's some of the error in my script, but I'm gonna undo. So maybe make it a bit smaller. Sorry. Here we have sphere, so I can move it. So in this case, I'm gonna move it to somewhere here, and let's make a boolean difference. Yeah, somehow it doesn't like. Sorry, it's maybe my script. Some part is error. So never mind. It's not important. So with the sphere, maybe my script is a little bit doesn't like this situation, but I'm gonna move it up and make it polygonal here, and let me make a box shape opening here once more, and then make boolean difference. So we have now this new opening, and let's calculate one more time in SOFiSTiK. Yes, so it works. So maybe the profile with a sphere near to this boundary was a little bit complicated for my script. Maybe that's why it didn't like it, but generally it all calculating it automatically, as you can see. 2 road case 1. I'm just curious one more time here, what if I go this geometry a bit more complicated shape, so like that, or maybe here. And so far so good. And what if I rotate it a bit and push it further? So we have this wall above the opening in this case. That's also interesting. Let's take but there is a collision between the beam, so I'll just delete the beam. So we have this scenario, right? So let's calculate one more time. This didn't go. Sorry, it didn't work. Maybe I'll undo. Let's push it a bit here. Sorry. Does it work? Let me undo. Yeah, just leave it here. For this case, I'll stretch. Yeah, it's okay. Maybe I'll rotate it a slightly front like this. Then we have analytical surface. So let's see if this gonna work. Maybe here I'll also move it a bit there, so it's like a little bit of differentiation. Now I'm gonna calculate. Hooray, it works. So one more time. Perfect. So it worked. Yeah, it's crazy. So this is like real power using Grasshopper and also SOFiSTiK, because of this instant revision or amendment. We can reflect on our structure calculation model. Again, this is like sort of one idea. There could be many different ways to work with it, but the important thing is that keep your logic, and as long as you organize your script how it should be, then at the end we can automate this workflow. I think that's all for today. I hope you enjoyed it. I was a little bit mucking around with unpredictable situation, but nevertheless the result was not too bad. So if you liked it, please subscribe my channel to support me, and also like the video. Then next time I'm going to show maybe something else that after I'm testing some new workflow. I have idea. Sorry. I have idea. Next time what we can do is maybe I'm going to use Rhino inside. So instead of this sort of abstract random scenario, I could reference Revit geometry without importing the CAD file, and then from reference Revit geometry using Rhino inside, we can automatically convert this sort of structural analytical model, and we calculate in SOFiSTiK. I think that could be very interesting. Alright guys, thank you very much, and bye bye.